Okay, onward with our next concept in our measurement unit, surface area and volume of a sphere. I'm on page 45. Here's a good example of a sphere, some sort of a fuel tank or gas storage tank, or is it a rocket launcher, whatever it is. It's a sphere shape. We have many things that are sphere shaped. The Earth, although that might not be a perfect sphere. Balls, the moon, many things in life are sphere shaped. So it can at times be useful to be familiar with finding the surface area and volume of a sphere. So with no further delay, let's learn how to do that. I have a couple sheets of paper and a calculator, which I neglected to do. And let's flip over to page 46 and have a look at the formula we'll be working with. Bottom of 46, the little brown box. Surface area of a sphere. The surface area SA of a sphere, when you know what the radius is, you got to know what the radius is, 4 times pi r squared. So surface area of any sphere, 4 times pi times radius, because radius squared. Why pi? Well, we're dealing with a circle. Spheres are round. So of course pi is going to be in here somewhere. Why are we multiplying by 4? Because you can fit 4 circles. If you were to take a sphere and cut it into round pieces, you would get approximately 4 pieces. If you could cut it completely accurately without wasting any tiny pieces, you would get 4 pieces, 4 circles that fit around the outside of that sphere. Typically you can split a sphere into 2 halves, and each of those halves could be covered with a circle. Of course, the circle has to be curved, bent, and so on, naturally, but typically you can fit 4 circles around the outside of a sphere. That's where this formula comes from. 4 times pi r squared. Surface area equals 4 times pi times radius times radius. Let's have a look at some examples then. Right on page 47. The diameter of a baseball is approximately 3 inches. Determine the surface area of the baseball to the nearest square inch. First of all, we have a diameter. We want the radius, which is half. So we're going to be working with 1.5. So once we determine that the radius is 1.5, we can proceed. So this will be on page 47. Sphere with radius 1.5 inches. And of course our formula, surface area formula of a sphere is 4 pi r squared. Surface area equals 4 times pi times 1.5 times 1.5. 4 times pi times 1.5 times 1.5. .3 inches squared. Surface area, so it's squared. If we're dealing with volume, of course it's cubed. Got another example here with the diameter of 4. So let's say sphere with radius 2. And so then we simply take our formula. SA equals 4 times pi times 2 times 2. .26. 50.3 inches squared. Let's look at one more surface area example, then we'll move along to volume. They have here on page 47 Yeah, I think 2 examples is good. Maybe there'll be another one that shows up later. We're going to leave the example on page 47. Move right on to the volume of a sphere. We'll find that on page 48. Bottom of 48. Volume equals 4/3, 4/3 pi r pi radius cubed. 4/3 times pi times radius times radius times radius. It's volume, so you have to multiply by the radius 3 times. You want to know how much air is on the inside of the cube, of a ball, let's say, or how much liquid you can put into a spherical tank, or how much rock is inside the moon, or I don't know, molten lava inside the core of the earth, whatever. You want volume is how much is inside something. 4/3 times pi times radius times radius times radius. 3 times. And again, we're dealing, notice the 4 shows up in the formula again, and again we've got pi, dealing with the same old circle stuff as before, similar, except this time surface area, or no, volume instead of surface area. So let's look at the 2 nice examples they're giving us here. The sun approximates a sphere with the diameter of 870,000 miles. What is the approximate volume of the sun? Well, first of all, half of 870,000 let's get the sheet under here. Page 48, 49, volume of a sphere. Volume of a sphere. And we're dealing with the volume of the sun with diameter 870,000. So what do we do here? Well, we want to divide that by 2 to get half. $870,000 divide by 2. 435,000 is what we get for that. So we have the sun with a radius of 435,000. Now let's go back to our formula. V equals 4/3 times pi times radius cubed. Right? So plug in these numbers. 4/3 times pi times this number 3 times. Times 435,000. And V equals pi we get an answer in scientific notation. 3.45 times the E on your calculator equals 10 times 10 to the power of 17. Okay, so 3.4 or 3.45 times 10 to the power of 17, a very large number. Like a billion has 9 zeros, for instance. This is a number with 17 zeros. So you're dealing with a number that's twice the size of a billion. Whatever that number is beyond, yeah. After a billion we get a quadrillion. This is clearly beyond a quadrillion. It's probably a quintillion or septillion, a heptillion, right? The point is, you're dealing with the volume of the sun. You're dealing with a massive thing, massive number. On the same page, they have the volume of the moon, which is also going to give us a massive answer. No, I don't think we'll do that. We'll move over to page 50 and do a couple of hemisphere examples. The hemisphere is almost the same thing. So this is page 50. Surface area and volume of a hemisphere. Half of a sphere is a hemisphere. Surface area and volume of a hemisphere. All right. This particular hemisphere has a radius of 8. Eight centimeters. Let's start with the surface area. SA equals 4 pi r squared. 4 times pi times 8 times 8. You're wondering why is he doing exactly the same thing? Because it is almost the same thing, as you'll see in a minute. 804.2. And because it's half of a sphere, all I have to do is divide by 2. And there's my final answer. You probably guessed that. 402.1 centimeters squared. So we're going to do exactly the same thing to find the volume, calculate the volume, and the only thing that's different is we divide by 2 when we're finished. So with the radius of 8, we have volume equals 4 over 3 pi radius cubed. 4 over 3 times pi times 8 times 8 times 8. It's cubed. 4/3 times pi times 8 times 8 times 8. 2144.7 centimeters. No, we're not done yet. Sorry. Divide by 2. (1072.3), and that's centimeters cubed. Same hemisphere is the same as a sphere for volume and surface area, except you divide by 2 at the end when you're finished. All right, that brings us to our homework. Page 51, write down the questions and I'll go over them. Page 51. 3, 4, 5. 3, 4, 5 on page 51. All right, let's take a look at those. Three, A, B, C, D. You're given either the radius or the diameter of each sphere. If you're given the diameter, such as for C and D, well, divide by 2. Find the surface area of each one. 4 times pi times radius squared, right? That's for the first part. Question 4 is then to find the volume of each one in question 3, right? So you're just going to go with 4 over 3 times pi times radius cubed. So let's look at the first one here, right? The surface area, 4 times pi times 5 times 5, because you've got the radius of 5. For the volume, 4/3 times pi times 5 times 5. Does everybody remember how to do this? I never showed my calculator. Remember with the brackets, bracket, 4/3, divide 3, bracket. That's how you put that, set up that 4/3 for the volume. So for this one, I do 4/3 times pi times 5 times 5 times 5. And that's your first one. So that first sphere has a volume of 523.6. So that's 3 and 4, finding surface area and volume. 5 is simply hemispheres. So you'll do the same thing as you did for question 3 and 4, but you'll divide your answer by 2 at the end. Here you're given a radius, here you're given a diameter. Good? Do we need one more example, or are we good? I think we're good. Okay, so just these very brief questions. And that is all for this lesson, and that wraps up the last concept that you need to learn for this unit. You are now ready to put it all together with the final review, and that will be the next recording. So that's it for this one.